Good afternoon, class. Today we're going to be learning about CPM and PERT. So to start with, maybe it's best to explain to you why it's a good idea to use CPM and PERT as part of management. So maybe first we can look at the differences. PERT, standing for Project Evaluation and Review Technique, is more about the time and trying to predict the time, or trying to get an accurate estimate of the time it takes for a task to occur. It focuses on trying to get the most accurate estimate, and it takes three different types of times: the optimistic, the pessimistic, and the most likely, to come to a conclusion about the most accurate time prediction. CPM is more focused on the activities and managing a network to represent the project logistics and schedule. And this helps managers to schedule, to organize, to accurately predict, and also allows for better budgeting, better organization in general of a task or a network of tasks, more effective task completion. It's also easier to manage when you use CPM and PERT, as it gives you really accurate and easy to understand format to projects and to the time aspect. Really, it's about the relationship between time and cost, and how to effectively bring down the time to then bring down the costs as a result. So just to summarize, both PERT and CPM are both very useful tools in any management position, and really helps to accurately predict and clearly plan and organize a series of tasks in order to complete the whole project. So class, now we're going to have a look at an exercise. We're going to have a look at both the CPM process and the PERT process. For the purposes of the presentation, I've pre-recorded a tutorial on YouTube. We're going to go through it as a class now, as a presentation, and look at each part step by step. So, without further ado.
Okay. So what I'm doing here is I'm just copying and pasting the data from the Your Data tab down here, and we're going to paste it in our front page where we have, and we're going to relate each type of time to each column. So we have pessimistic, we have most likely, and we have the optimistic results. So yeah, just copy and pasting. Finally, the optimistic data. And now we've pasted that. Okay, so the next step that we're going to do is we're going to find out, or we're going to have to take we're going to have to find out how many pieces of data there are for each type of data of range. So for our pessimistic range, we're going to have values of greater than 5. For our optimistic, we're going to have values of less than 3. And anything in between will be most likely. So now we're just going to type that down here in the bottom left hand corner. And we're going to put in some functions which will give us a count for each of the pieces of data. Now the whole data set is what you can see here on the screen. So we're going to take the whole data set, and we're going to put a little COUNTIF function for each of the three categories. First of all, we're going to do the total, so we get a number of pieces of data, so we're going to do the count for the total, and that's our full data set. And that gives us 72. So we have 72 pieces of information in these three columns. Now we need to find out how many are in the pessimistic value range, so anything greater than 5. So we do a COUNTIF. We first have to pick the range, which is again the whole data set. And then we need to give it a criteria. We're going to do this by doing some speech marks. And then we put the greater than or less than 5. Apologies, greater than 5. Close the speech marks, close the brackets, and press enter. Now we're going to do the same for the optimistic. So we go down to the optimistic and we do the exact same thing, but instead of this time being greater than 5, it's going to be less than 3. So we'll see how that turns out. As we can see there, just entering the less than 3. And when we return that gives us a value of 16. So we now have 11 pessimistic values, 16 optimistic values, and the remainder will be therefore most likely values. So what we can do is we can take the total, we just take away the optimistic and pessimistic values from the total, and we get our most likely. So now we have our data and we've categorized it into 3 different pieces, or 3 different sections. The next thing that the question requires us to do is we now need to find out the expected time. So we basically just need to complete the rest of the table that we have up here. We have 24 different steps and we need to calculate the expected time for each step. So we're going to do that by taking a weighted average. So we're going to take our value for each step and we're going to divide it by the count. Sorry, times it by the count. So we take the best pessimistic and times it by the pessimistic count. Then we add that to the most likely value times the most likely count, which is 45. And then we do the same for the optimistic. So we take our optimistic value for step 1, times it by the count of optimistic results there are. And now that we've got all those, we need to put brackets around that data. And to find out the average time of all that, we then need to divide it by the total count. So the number of pieces of data. And there we get our weighted average, which for step 1 is 3.64. We're then going to lock in, because basically we want to drag this down. We don't want to repeat everything that we're going to do. So we need to block in some of the numbers. Now as we're dragging down, we block the numbers, not the letters, which is why the $ has to go in front of it. And because these are the ones we want, these are the values we want to keep the same, because these are going to keep going down each time for each expected time. However, we want these ones to stay the same. So we're going to do the $ for the C30, the C31, C32 and C33. And those are these 4 boxes just here. Now we need to calculate the variance. And to calculate the variance, what we're going to do is we're going to do the pessimistic value, take away the optimistic value. We're going to divide that by the total count, and then we're going to square it. So raise it to the power of 2. So what you can see happening here, you need to put brackets around that. We're actually going to put a second bracket in there because we're going to divide it by n, which is our total count value of 72. And then we've got to put a bracket around that again, and we've got to raise it all to the power of 2, squaring it. And then basically what that does is it makes it a positive value, because sometimes if the pessimistic value is less than the optimistic value, which it would be in this case for step 1, we're going to have a negative number, whereas we want everything to be positive. As it's a plus or minus, it could be both, but it's easy to look at it in the positive format. So we're just going to square that to ensure that it's positive. A negative times a negative, remember, is always going to be a positive. So now we need to construct our CPM graph. What we're going to do is we're going to create a little template. So this is how our box is going to look like. We're going to have the early start, the step number, so we've got the number of steps here in the middle at the top. We're going to have the early finish, which is our EF value. Then on the second row we're going to have our slack. Both of these boxes should equal the same, as the slack is calculated from the late start minus the early start, or alternatively the late finish time minus the early finish. And then at the bottom middle we're going to have the duration. So that's a little template of how each box is going to look like. And now we need to replicate that, but put in the values for, and we need to make one for each step. So we're going to create the first box. We're just going to move it down a little bit. We don't want it too close to the template, just to make a bit of a distinction. And we're going to enter the formulas first, just so that it creates a little less, or makes a bit more clear what we're doing. And we can just copy that for each box, for each of the 24 steps, and then we can input the actual data afterwards. So basically we know, as I said before, that the slack is the late start minus the early start, or alternatively the late finish minus the early finish, which is what I'm doing here. You can see the late finish minus the late start, sorry, the early finish, sorry. And now we know that the early finish must be the early start plus the duration. So we can put that in. So there you go, the early start, top left box, plus the duration, and that's going to give us the early finish. Now to get the late start, what we do is we're going to take the late finish minus the duration, and then we'll get the late finish. Now we're going to select that all, we're going to copy it, and we're going to paste it 24 times. But what we're going to do is we're going to look at the predecessor for each step, so that we can put it in a vague order. What we're also going to do is we're going to add some arrows at a later stage, just to make everything a bit clearer as well. So now this is our first box. We know that the second step is followed only by the first step. So we can put that in a direct straight line going from step 1 to step 2. The same with step 3, it follows only step 2, so we can just paste that, and the same with step 4 as well. Again, it follows only step 3, so we can just paste those all in a line. Now step 5 gets a little bit more tricky, as step 5 follows steps 2 and 3. So steps 2 and 3, we have to make sure that we can put an arrow to step 5. Step 6 only follows step 4, so we can paste that straight after step 4. And step 7 follows both 5 and 6. So we paste that in a position where both 5 and 6 can have arrows drawn to 7. 8 follows both 6 and 7, as we can see here. And then 9 follows only 8, so we can put a straight line from 8 to 9. Number 10 follows both 8 and 9, so we need to put that below, so they can follow both those two steps, step 8 and 9. There's step 10. Step 11 follows only step 9, so we can put a straight line right above step 10 from 9 to 11. Step 12 follows 9, 10 and 11, so it follows 3 steps. So all 3 of those boxes over there that you see need to be accessible to step 11. So we're going to put step 12 up high. Then we have step 13, it follows only step 12, so we can draw a straight line from that. And step 14 follows step 10 and 13. So now we have step 10, which is this one here at the bottom, and we have 13, which is the most recent box we put in there. So if we put step 14 around about where the cursor is now, then we can have a nice easy connection between 10 and 13. Then step 15 follows only 14, so that's going to be a straight line after 14. Step 16 follows step 14 and 15, so we're going to put that below so that we can draw arrows from both those boxes to step 16. Step 17 follows just 16, and 18 also follows just 17, so the next 2 boxes we can draw in a straight line. So we have step 17 being painted now, and step 18 as well. Then 19 follows 17 and 18. So we have to put one below, so we know that it's going to follow 17 and 18. And step 20 follows 18 and 19. So again, the last two steps, we need to be able to follow that with step 21. So we're going to put it there so we don't forget that it's got to be followed by both the previous ones. Step 22 follows step 21, step 23 follows step 22, and step 24 follows step 23, which means the last three boxes we can draw in a straight line as well, and makes it easy for the final calculations. We just need to copy it. Apologies, I skipped step 21. Step 21 is followed by 20 and 17. So that's what I was explaining just previously. Now the last three are going to be in a straight line as they follow each other in a sequential order. So there we go, 1, 2, 3. We're going to skip a little bit. Okay, now what we're going to do is we're going to put the steps in each box so that we know which box refers to each step. So we're going to put 1, 2, 3. Just doing what we did last time. We're going to skip a little bit as it's repetitive. We're just going back over the steps that we did before, just reminding ourselves, putting in the numbers to have it all nice and clearly organised so we don't get confused between boxes. And here we go, continuing as we were before, just putting the numbers in each box. We're on number 20, we just got to fill in the last few, which we'll skip over. There we go, and 24. So now if you're using a Windows machine, or perhaps on Mac as well, I don't know, I haven't experimented, but we have this tab at the top called Draw. With Draw we can draw some arrows, and we can also do ink to shape, so it makes it slightly neater arrows for us. So we're going to go ahead and click that, and we're going to start drawing arrows between the boxes, again remembering the order in which they go in and which the predecessors of each step is, just to make sure that we've got everything nice and clearly organised. So we just draw in like that and it will automatically convert it to an arrow. We're going to do that remembering the order for each box, and I think we can skip forward here as this is pretty repetitive and just shows what we know already, the order that is already been created for us. More arrows going in. You can see now as the steps have more predecessors, we've got to put in more arrows from each box. You keep going. Again, this isn't essential, this is just in case you want to have a bit of added clarity for yourself. It does help, I certainly find it helps me, but if you prefer to not put in the arrows, then that's up to you. We're just going to again skip forward a little bit, as it's a bit repetitive. Okay, so now we need to input our duration into each box. We've got all the arrows, we've got the numbers, and we've got the order all sorted out. So now we're going to just start inputting the expected time. So this is, whenever we say duration, what we mean is the expected time, as we've done our PERT analysis, which was this stage here, calculating the expected times. And now we use those expected times to put into each box. So what we're going to do is we're just going to copy and paste these values into each corresponding box. However, as we know the cell value, or the cell number, we can just straight away type in F followed by the corresponding letter that it refers to, as it's in the F column up here. Again, this is a little bit repetitive, we just need to make sure, so 7 is going to be F10, 11 is going to be, 8 is going to be F11, 9 is going to be F12, etc, etc. So again, this is something we can skip forward a little bit. There you go, 10, 11. Just make sure obviously you got these numbers right, you don't want to be getting them wrong, otherwise there's going to be an error in your working. So keep going, step 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 and 24. Right, so now that we've done that, we need to enter the early starts. Obviously, we start off with the first step. The earliest we could start, or in fact, well, yes, the earliest we could start would be 0. So this is our base point, we put in 0 as our early start. And you can see here that the early finish is already the correct value, as it's got the formula from before, which is the early start, plus the duration, and that gives us the early finish. So now we know that the early finish for step 1 must also be the early start for step 2, as the earliest you can start step 2 is the earliest that you can finish step 1. They're in order, so 2 has to be after the first step. Then we just continue to do this. Where we have a straight line, it's fairly straightforward. We just input the early start from the previous one. Now for step 5, we have 2 predecessors in step 2 and step 3. And so what we're going to do now is we need to choose the maximum value, as we can't start any earlier than the latest time that any of the previous steps finish in. So that means that if step 2 is 6.59 and step 3 is 10.07, we couldn't start before 10.07, as step 5 has to have step 2 and step 3 completed in order to be able to do that. So that's why we select the maximum value, as it will give us the first possible time in which we can start step 5, which also happens to be the latest time that any of the previous steps finish in. And we continue. And again, whenever we have a step which has 2 or more predecessors, we just take the maximum value of the possible early finishes to achieve the early start. And we're going to skip through this because you can do this on your own. It's pretty straightforward. Again, for number 8, we see that we have predecessed by 6 and 7. So we put in the max value of the early finishes from both stage 6 and 7. When it's a box that has multiple arrows leading out of it, so you see here 8 is followed by step 9 and both step 10 as well. So in this situation, it doesn't matter for the early start for the consequential steps, as it's both going to be the same. They can both start as soon as step 8 is finished. It's only when you have a step which is preceded by multiple or more than one steps beforehand, that's when you need to choose the maximum value. Again, we're going to skip ahead of this bit a little bit. So step 16 being filled in now. Again, we're just doing the early start and the early finish for the time being. So step 18. Again, we're just going to skip ahead a little bit, as this is the same as what we were doing before. So 20 is the maximum between step 18 and step 19. 21 is the maximum between step 17 and step 20. And then the last ones again are in a line, so it's just going to be the straight up early finish value from the previous step. Okay, so now that we've entered all those values, we now have the final time that it's going to take us to complete the project, which is that 85.1987. That's also the critical path, as this is the longest possible time the project could take to finish. As a result, we know that the earliest it's going to finish is also going to be the latest we want it to finish. We don't want the process to end any later. We don't have a flexibility in our timetable. So we say that the early finish of step 24 is also the same as the late finish of step 24. We then need to go backwards to find out where, if at all, there are any processes which have a bit of slack to it. So in order to find the late start of the, in order to find the late start, we do the late finish minus the duration, and that will give us the late start. So we work backwards. So it's again the late start of so the late finish of any step is the late start of the step that it is followed by. So for example 21 here, for step 21, the late finish for 20, 69.9037, must be the late start of step 21, because the latest step 21 can start can't be any later than the latest that 20 would finish. As 21 has to come after step 20, so it needs to be in order, and the latest possible time that step 21 can start can't be later than the latest that step 20 finishes. And then as we've input our formulas already into each box, it'll automatically calculate the late start, as it will take the duration away from the late finish to then calculate that late start. Now, when we have a box which feeds into two latter steps, so for example here 18 is followed both by 19 and 20. So what we're going to do here is, because the latest that we can finish step 18 can't be later than the late start of either of those stages, of stage 20 or 19. So we know that it has to be the minimum. So whichever the minimum is, the latest, the minimum, or the earliest, the soonest possible late start for 20 or 19 must be the latest time that step 18 can finish. So for that reason, we need to put the minimum value. Because imagine if that was for right now, the 61.54, the late finish for 18, is the same as the late start value for number 19, not 20. This is because 20 is 65, so it's higher than 61. And if we were to say that the late finish for 18 was 65, then 19 couldn't possibly have its latest possible start at 61, as it needs to follow step 18, and step 18's already been, well, we've already been told that the latest that 18 can finish is 61. So if it was 65, then it wouldn't work. And again, step 17, it has three possible boxes or three steps that it's followed by: step 18, 21, and 19. And again, we just take the minimum or the lowest late start time from those three boxes. And we go through the process, going from back to front, the other way around this time, taking the minimum value where we need to. If it's just preceded by one box, then again we just take the straightforward late start value as the late finish. We're going to jump a little bit. So normally, as we're following the critical path, we shouldn't have any slack time, as that would be the indicator of the critical path. It's the longest time that a project can, or the path of the longest time that the project takes to finish. So therefore, in stages where there's no slack time, it's the maximum time of the project, or it's the longest routes that the project can take. To determine our CPM. So therefore, where there is slack, we know, so for example, step number 10, we can see here that the late start is not the same as the early start, nor is the late finish the same as the early finish, which means that there's slack. This slack means that step 10 has a bit more leniency in the time it can be taken and the costs associated with that. And so we can say here that 10 is not going to be part of the critical path. And with step 5 as well, we can also see here that there is slack. There's a little bit more slack this time. And so we can see that step 5 also is not in the critical path. If we just skip ahead, last one, number 1. Okay, so what you can see here is that Excel has a slight rounding error because they're numbers with so many numbers after the decimal place. Sometimes there are some slightly rounding errors that get made. So where you see here minus 5.77 to the e to the minus 15, essentially that means that the decimal point is moved 15 places to the left. So we have, first of all, 0.5, and then 0.05, 0.005, and continuing until we have 15 places the decimal point is moved to the left. That means it's a very, very small number. It's going to be 0.000000000, etc., which means that we can essentially just say it's 0. It's just that Excel's made a rounding error. We know that in reality it would be 0. So what I've done here is I've just replaced those e to the minus 15 numbers for zeros, which makes it clearer for us and is also reality. And you can see here now we've completed our CPM graph. We've calculated the root, we have our critical path, and just to make that a bit clear, we're going to highlight the steps which make up the critical path. So step 1, as it has no slack, we know this is in the critical path, so we're going to give this a little highlight. There we go, we're going to put it in yellow. Step 2 as well has no slack, we put that in yellow. And again, we basically, for any box that has 0 in the slack time, we can just highlight that in yellow. We know step 5 has a slack time, so we don't highlight that in yellow. The rest of the steps we will highlight in yellow. Again, step 10 is not part of the critical path. We're just going to select all the ones that have a slack time of 0 and therefore make up the critical path. There we go. In fact, it's just step 5 and step 10 that have slack times. So the rest of the steps are all part of the critical path. So this is obviously useful in real life because it tells you which steps you can afford to take a bit more time on. And when time equals money and money equals costs in this scenario, it's very important to get this right as we can maximize profits and also reduce costs with more efficient organization. Right, so now that we've got our critical path, we're going to just start doing the step 4 of the question. So we need to see first of all we need to calculate our CPM time, which, as was said before, is both the early and the late finish for step 24, the last step. So we're going to highlight that in the green colour just to make it stand out and just for us to recognise that that's the CPM time. Now we need to find out the variance, so we take of all the steps. So we need to take first of all we take the sum of all of them, and then we need to take away the steps that did not contribute to the critical path, because we need to find the variance of the critical path. So we take our variance, our total, and we take away the time, or the variance for the step 5 and for step 10, as those were the 2 steps, if you remember, that weren't included in our critical path. So there we go, it's taking away step 5's variance and step 10's variance there, to give us the variance of the CPM. Now the next thing that we need to do is we need to have a look at the standard deviation, and the standard deviation is calculated from square rooting the variance. So if you remember before, we had to take away the pessimistic from the optimistic and divide it by the total count of statistics, and then we have to square that number to make sure that it was positive. Now obviously when we square a number we change its fundamental characteristics, so to take it back down to the right level to find the standard deviation we need to square root it, and that's what we've done right there. So you can see now our standard deviation is a pretty small number, 0.119269156. The next stage we need to do is to calculate the z-score. as our z-score is the z-score is calculated from the expected time minus the CPM time, and we're going to divide that all by the standard deviation, which you can see is what I'm doing there. So now what we're going to do is we have the z-score, as we've got the percentage or the certainty percentage that we want to obtain. Just to explain, the 95.05%, what that refers to is the percentage certainty level that we want to have of finishing the project within the CPM that we've already just calculated. Because obviously we've calculated the CPM, but we can never be, well, we can only be certain to a certain degree. Even if it's 99.9, it's not quite 100%. So what we've done is we've taken, in fact we're going to rewind a little bit. So we go to the normal distribution table, we know it's 95.05%. So we go here to this table, 1.6, we find 0.9505, and we take 1.6 and 0.05. If we add those together, that gives us 1.65, and that's our z-score if we want a certainty of 95.05%. Now that we've obtained that z-score and we have our calculation, we just need to define the time, because the question part 4 asked us what is the time where we can be 95.05% sure of completing the project within the budget time. So we have our standard deviation, we have our z-score, so we're going to multiply those together to get, and that's going to give us 1.967, etc. Now this is the difference between the expected time and the CPM time. So what we need to do to this now is, if we add that to the CPM, remember this can be plus or minus, because the percentage certainty can also be, you can also do less than what you predict. So you can finish it in 85 days if you predicted that it's going to take 86 days. Or you could also finish it in 87 days if you predicted 86 days. So it's plus or minus, that's where the plus or minus comes from. So our certainty is going to be that plus the CPM. And now with this number, that's the amount of time that we can be sure that we will finish I'm going to rephrase that. This is the number 85.39, etc. is the number, or is the amount of time that we expect to finish in if we want to be 95.05% certain of finishing within time. Okay, now we're going to see just a little explanation. There you go, just as I said, it's now typing it up on the screen. The amount of time to be 95.05% certain of completing a project within the time limit. Okay. So that just about wraps up today's class. Thank you very much for listening, everybody. It's been fun teaching you all about CPM and PERT, and if you have any questions, feel free to raise your hand now.